Okay, good morning again. Sorry for these technical steps. Science. So, welcome to the fundamentals of communication networks. This is the first lesson of this course. I am Guido Maier, and just to welcome you, this is what we will talk about. Students of this course, I think they come from traditionally telecommunication engineering and maybe also internet engineering, but from this year also bioengineering. How many of you are from bio? Okay, good number. So this year the attendance will be international, but probably with some majority of Italian students. So up to now there are 17 registered students, but I think that registrations are still open, so maybe this number is going to increase. So this course is about fundamentals of communication networks, and today we will go through some basic informations about the aim of this course, and we will start to look the general concepts that are at the base of what we are going to tell into the details. So first of all, just to introduce myself, I am Guido Maier. I work at the Department of Electronic Information and Bioengineering, which is just across the street. So you can find me in building number 20, third floor. That's the phone number and my email that you can use for anything that you may need. About how to find the documentation for this course, I use Beep, which is the portal for teaching, and so I will upload in Beep all the what you need for the course, except maybe some software tool that I have still to investigate how to upload. And if you need me for questions, anything, this is the official office hours. Is on Thursday, I think, if I'm not wrong. But since usually these office hours have no attendance from the students, please announce yourself by sending me an email, and with an email, so I know that you will come. I don't stay there waiting for nobody. But also by email we can arrange an appointment, or even in another time if you're not comfortable with this time. I will teach all the part of this course, so both lessons and practice. But there is another person, Sebastian Troia, that is our PhD student, who will be available to help you maybe in the last parts of the course, so towards the end of the course, as a tutor. So if you have questions or you need help on some topics, he can be reachable. Okay, the email is the same, sebastian.troia@polyme.it. Actually, I asked for so-called Didattica Integrativa, is support from the school for this service, but since this course is for a small number of students, they didn't give us anything in terms of financial support. So basically, Sebastian will go will do this tutoring activity for free. So be kind with him. Regarding the textbooks, the best textbook is Computer Networking. That is from by Kurose and Ross, and there is also the Italian language version, which is really identical, and is the 7th edition. In this edition, there are some changes compared to previous editions. So, if you have to buy the book from scratch, you should look for these editions. If you already have a previous edition, it doesn't matter, because we will follow this book, but very loosely. So basically, you should rely upon the slides of the course and use the book only if you have, if you want to understand other topics that are not covered in the course. So the material is based on lecture slides that will be available. You have already the first slide set uploaded in BIP. I try to upload the slides in advance, but not always is possible. So, for example, the first slide set was uploaded this morning. For the next days, I will try to upload them with some more earlier compared to the lesson. I will try to do my best, but I cannot guarantee. But in any case, you will always have the slides uploaded, sometimes before the lesson, sometimes just after. And obviously, these slides are subject to be reviewed, so you will find a version that is uploaded on the slide, but maybe after a few days I can upload another version. You will have a version number, so you can take the last one. And during practical classes, you will have notes, but I will also upload the exercises. And then, if you want, you can. I will try to put some links to further readings, papers, and so on. And in the first part of the course, I will use also some demos to show you something that is not a real lab, but at least a virtual lab, something online to be more hands-on. And I will try to put also the software that I will use during the lessons in a repository, so that you can download it and try to, if you want, you can use it. This course doesn't have labs, which are instead in the 10 credit version of the course, because 5 credits is really a very short time. So we don't have labs, but I will show you something of practical. Since these tools are large, I cannot upload them on BIP because they are too big. And so, for example, you can download them from this other address, but I will try to look for another location. And I'm going to record the lessons, so you will have a voice and slides recorded. And I will set up a YouTube channel, so you can, if you miss a lesson, you can look at these videos. I still have to work on it, so not immediately, but I will try to do it. So about organization, we'll have roughly 30 hours of lectures and 20 hours of practical classes. I will try to put a practice session at the end of each topic, so you have the theory and then practical application in terms of exercises. And for the demos, I will tell you if you when you will use some of these tools that I was mentioned before. So you're suggested to bring your laptop, so you can maybe also do something during the lesson for a hands-on experience. However, we don't have time to do this in a very good way, that it means that I wait for you until everybody completes exercises. This is impossible, but maybe somebody can can do something similar. So this is the timetable. We have 2 hours today, 2 hours tomorrow, 10 to 11. Sorry, 10:50 to 11:45 if you want to cut off the so-called academic quarter of hour. But what is really important is to understand is how many overlappings you have, because I already received emails from somebody of you who have overlappings with some other courses. So this is the timetable of all the courses in the master. As you can see, there are no hours in the week where you don't have overlappings, except if you want to sacrifice your lunchtime. So I would like to know how many of you have overlapping lessons with this current setting. 1, 2, 3. And when? Today. Operational research. What? Operational research. Operational research, right? No. For you. For me as well. Operational research. Digital. Okay, the problem, the operational research basically, this course should come before taking the other course, no? Because operational research is associated with network design. So in principle, you should choose one of the two. Digital signal processing. Do you have digital signal processing? And audio signal. And audio video signal. So with audio video signal, what I can do is to ask the professor if he wants to start earlier. So in this way you will have just 1 hour overlapping. But maybe I can start on Wednesday. I can start later, so you have less overlap. I already talked with Macron, and he agrees, but he will start in the second half of the semester. I have to talk to Sati. No. Sì, ma... Okay, I try to investigate. This is solvable. Regarding digital signal processing, non è un problema particolare, secondo me, me ne sai un po' prima e comunque solo un'ora di organizzazione. So maybe also today I can start later instead of starting at 10:15. I mean, I can start at 10:30 and then finish at 12:15. So in all, 5 Okay, so I will try to check about this and let you know. Exams. Okay, you will have the regular course. There are no compitini because the course is very short. And the exam is written. You will have 3-4 exercises similar to those presented during the classes, plus questions on the theory part. So maybe open answers or quizzes according to. And then since 2 years ago, we introduced this method in the equivalent course of 10 credits in Laurea at the first year. That is online quizzes using an application that is Kahoot. And it's a lot of fun for the student, but also a good way to understand if you are aligned with the course and if you understand, if you have understood the topics. So I will, if you agree, I will use it also in this course. It means that at the end of each chapter or at the end of each part, we will do this Kahoot, which is an online quiz you can access with your smartphone or tablet or whatever. The only important thing is to have a good connection with the network. And then I will ask you some questions. You will have 10 seconds for it to answer each questions. They are quiz, so just you have to click on the right answer. And then I collect all the results. So at the end of the year, I can assign you some bonus extra scores for these Kahoots. So we will test it tomorrow, just to try. The oral test is rather exclude it, except for very exceptional cases. If you have questions, of course, you can interrupt me and ask anything also while I am speaking. So, to go more on the topic, what is the aim of this course is to build your background expertise on internet. If you are attending this course, it means that you have not received the course in your bachelor about these topics, about internet, about networks, or you have received a very short course that is not explaining all the parts and so on. So in any case, in this course you need to receive the basic informations about the network in order to be able to understand courses that you will attend in the remaining part of your track as a master student. So the focus will be on how a computer network works, what are the basics of internet, which is used today, as you very well know, in thousands of applications that goes from audio, video, telephony to messaging, maps, navigation, so on and so forth. Internet engineer, somebody who is able to design networks and today, so in a way that is useful for the current market, should not only be able to understand the basics of the network, but also to understand how this network is interfaced with the applications. So it's very important to be able to control the interaction between applications and the network. Configure network components, forecast the behavior of the network in order to compute the performance, monitoring the system, but above all, be prepared to network technology changes, because the networks that we are explaining today next year will be different if you go out in the market. In this field, in this area, evolution, the technological evolution is really very fast. So it's really important to grasp the basics in order to be open to technological innovations, and you cannot it's impossible that somebody is able to learn all the details of protocols and technology and so on that are used in the network, hoping that it will not change. So surely there will be updates in terms of technology that makes your part of your knowledge obsolete very soon. But if you know the basics, you can easily adapt your expertise to innovation. Why do we need a data network? The main application is to allow, the main goal of a data network is to allow execution of distributed applications. Distributed applications are computer programs that are in execution on different computers located in different areas, and they exchange data using internet in order to be able to execute those applications. So for example, if you just think of a simple case, you want the weather forecast, you have access to the internet through a device that can be a smartphone or a PC. When you require a weather forecast, you receive information, but even if you don't realize it, the result that you receive is the final result of a very large distributed application. In fact, you have the forecast centers, weather centers that are receiving data from meteorological data from the land, the territory, elaborating computing models, and then distributing the results to the servers of the providers who you will access in order to get forecast, for example, say 3D Meteo or Meteo.it, something like that. These are distributed on a set of servers that may be placed in different locations according to your position. You access one server or the other, because this is called cloud. This is the cloud, so it means that the application data are in the cloud. So when you receive information about the weather, actually this is the final result of a very large distributed application. In the past, things were different, and for instance, computers were completely different. In most cases, they were isolated mainframes or even supercomputers, but completely disconnected from one each other. So it was typical that when you wanted to exchange data between different computation sites, you have to manually take this data in terms of tapes or floppy disk. Maybe somebody of you know what is a floppy disk, but my son, for example, completely knows this. Or even in the past, more ancient past, you had these punch cards that you had to bring manually to the computing center. This doesn't exist anymore. On the side of computing, so on the, let's say, computer science side, on the telecommunication side, in the past you had networks dedicated to specific services. For example, the telephone network, the so-called plain old telephone service, also known as POTS, was widespread, but used only to convey voice, okay? To transmit voice because of the phone calls. And this also does not exist anymore because the network is used for transferring any type of data, not just a single service. What is the scenario today? When you want to develop an application, this is how software is written nowadays. First of all, you write the server components. Maybe you also create virtual machines in order to be able to execute this software everywhere in the network, and so the virtual machines can be then uploaded in the set of physical machines that compose the cloud. Then you have to write the client components, maybe for different platforms if you want that your application is successful. So, for example, Android, Apple, and so on. Then upload the client side on the related stores, online stores, and wait for the users to download these applications, and then you can start running the service. So you can see that it's really an interplay, continuous interplay of computer science and telecommunications. And today there is also another new paradigm that has been recently proposed, not so recently actually, some years ago, but it is still spreading around in the networks. That is a different vision on how to control a network, so the so-called control plane. And a network is seen as something that is very similar to a software environment, and by using this approach, you are able to make your control plane of the network much more flexible, and you have programmability you can use to modify, for example, routing or the way you assign resources and so on and so forth with writing simple applications. These applications are similar to the apps that I have described so far. The only difference is that they act on the control system of the network itself. So by these applications, you're able to control the behavior of your network. This is called software-defined networking. So the conclusion is that when you want to build your own know-how in ICT, you need knowledge of both computer science and telecommunication world, and the best background for an engineer is to be able to master all these methods, so be able to develop application and also to design networks and communication services in the same way. So in this course we will focus obviously only on the blue part, but since we are also talking about the application layer, you will also have insight on what happens in terms of applications. Questions so far? So, before going on and introduce you to the program of the course, let me just give you a very brief historical overview of this topic, starting from the concept of telecommunication. So telecommunication means to communicate at a distance, The distance can be in space, means you have to transfer data across from one side to another side, which are spatially or geographically distant, but also maybe in time. You write something, you you create an information, and you want that this information is used not immediately, but maybe after a while. So in this perspective, there are a lot of achievements that the mankind has reached in order to invent devices to make this communication possible. These are the main one, if you want. And for example, if we think in broad terms, writing is a telecommunication means, because by writing something, you can communicate at a distance in time. What you write can be read also not now, but maybe after a day, a year, and so on, and even ages. The mail was the first service invented to cover geographical distance, so send information from one point to another, and creating a structure, a network that allows this information to be relayed from the source to the destination. Press is an evolution of writing that mixes together also new technologies with the basic concept. And there are many other examples of telecommunication, for example, signaling from distance points using sounds or lights. And finally, sending messages with electromagnetic waves. This is the evolution that occurred really in the last 2 centuries. Before it was not even imaginable, but it's what led us to the current situation where we have all these services. And we started from the invention of telegraph. The human beings started using electromagnetic waves to send signals, and also they started building networks that are able to carry these signals around the globe. They came the telephone, the radio, but it's only with digital revolution and with the invention of computers that we are coming to the final step, that is computer networking. That is the objective of this course. So now we have internet, mobile communications, and so on. And you can see that this is concentrated really in the few last decades of human history. So, going to the internet. Internet was born in the 60s, and on the side of research, the enabling knowledge came from study of queuing theory and packet switching. We will see later what is the difference between packet switching and the type of switching used in the previous networks, like telephone networks. And then what is known to be really the ancestor of internet is a specific project that was launched by the Defense Agency of the United States, that was called ARPANET. And basically, this project came out initially as a military initiative, because that times we were in the so-called Cold War, and so United States was really worried about possible attacks that could be carried by, at that time, so the Soviet Union, to their communication infrastructure. And their communication infrastructure was basically the telephone network. The telephone network has a very peculiar aspect. It was very vulnerable to attacks because in a telephone network, as we will see, when you set up a communication between two endpoints, the path that signal takes throughout the network is predetermined. So you don't have many alternative paths. And everything tends to be centralized. So if you hit one of the switching centers or the central offices of telephone network, you may very easily destroy the entire network. So the militaries wanted to investigate the possibility of sending information in a more robust way, and they understood that the packet switching was a solution. So they took the best scientists that were working on packet switching, set up this ARPANET group led by Roberts, and they gave them some money in order to demonstrate the concepts that were studied so far. And the demonstration came in a very short time. This is IMP, which is Interface Message Processor, which is really the ancestor of the current router, the main device of the Internet. At that time, it was a modified computer, and these machines were located initially only in 3 sites, 4 sites. And they correspond to these the circles that you see in the picture. This is a very famous picture and made showing the first implementation of ARPANET. And as you can see, the idea was already to dedicate capacity and use a special device specialized only in managing packets. Okay, that was different from the terminal. Okay, at that time, terminals were the supercomputers located in those universities that are mentioned there. So they took a computer, at that time state-of-the-art computer, and modified it in order to use it only to manage packets. So these devices were computers, so they needed operating system, or software that could be used in order to make them manage this packet in a good way. And this is why the NCP network control protocol was defined and built in '72. It was the first software used to manage packets, so it could be installed inside these nodes in order to make them work. So it was the first embryo of the Internet protocol that later developed. And then in the 70s, the ARPANET project started to grow. So other nodes were added to the network. And then there were a lot of other evolutions. For example, Cerf and Kang are considered two of the many fathers of the Internet, started to define the principles of internetworking. Other technological innovations were produced in the area of transmission systems used for networks. For example, radio started to be used to send packets in the AloaNet, that was a network connecting the University of Hawaii that had different sites on different islands. So the radio was the only solution possible. And at the same time, Ethernet was invented at SEALS laboratories, and Ethernet is today really the main, absolutely the main, most important protocol that you can use to connect the various pieces of the network. In the 80s, there were other evolutions, and other parts of the network started to interconnect to internet. We're implementing the first international connections. Protocols started to be defined also in the application side. For example, SMTP, that we will look at in a brief way, was the protocol developed for email. And more on the control plane of internet, very important is the release of TCP/IP protocol stack. As we will see, TCP is making the transferring of information on the internet reliable, which is a feature that the only physical part of the network cannot guarantee. Then we have the invention of DNS. So you can use humanoid symbolic names instead of IP addresses that are numbers in order to identify the different sources and destinations. FTP protocol, congestion control mechanism, and so forth. Thanks to these evolutions, we have the first applications, for example, email applications to manage the mailing system, FTP to transfer files, Telnet for remote terminal. All these applications were characterized by command line interfaces. So users were using these applications by typing on a keyboard on a line of text. Then in the 80s, the main revolution is the invention of the web by Berners-Lee, who was actually a British researcher at CERN in Geneva, and he invented this system to make it more easy to exchange documents, in that case scientific reports, between people working in the same community. And so it was able to associate the idea of transferring information with HTML, so the idea of writing a text with links that are clickable and can dynamically lead you to another document. And this was really a successful invention. And also on the side of the interface towards users, we have the first programs adopting the GUI, graphical user interface. For example, Mosaic and Netscape were the first browsers, and then later on. And also the web was released for commercialization, so ARPANET was decommissioned. It was the infrastructure was transferred to NSF, which is the scientific scientific agency of the United States, and NSF started to drop the restrictions in order to make it usable also for commercial purposes. So we are coming close to our days, and in the first years of 2000, we have all the killer applications that you know: instant messaging, peer-to-peer file sharing, telephony, social network. Also, techniques to make the network more secure, because now everybody can have an access that is potentially connecting everybody with relevant information, also sensible information of other people. And we have a very big expansion in terms of users, hosts, the speed of communication systems that are going to the order of gigabit per second. And so we come to nowadays where we have the last technological evolution, which is the explosion of the mobile internet. So with the mobile internet, what was available in the past in a fixed positions is now available everywhere. And with the smartphones, you can have access to very complicated distributed applications, what we said before, with the difference that now the terminal is moving around the network, so you need to support also this. And the other important fact is the video content. The video content is becoming dominant in terms of traffic generation, because as you may know, when you want to transform a analog content that is something that we can interface with our senses, like sound or video and so on. The quantity of digital information that we produce depends on the type of content. So with audio, or even with telephone voice, the quantity of information you produce is very limited. But when you want to go through to the video, then the amount of digital information is very large. So the same, to say, two contents of the same type, of the same duration, can be very different in terms of information, digital information, if the one is audio and the other one is video. So this is why now the video has become the dominant traffic factor. For example, Netflix and also YouTube are, I think, the most the two topmost applications in producing information that is carried in the internet. Maybe the next step will be virtual reality and augmented reality, which requires even more in terms of traffic. So this curve shows you the evolution in terms of host count. Hosts are the terminals, as we will say later on. And you can see that the evolution has been exponential for a long the increase has been exponential for a long period. Nowadays seems to reach an asymptote, but we don't know exactly when it will stop. So this is just a very short overview, and I want to go now just to the to show you the course program. Two words about the program that you may find in the formal set of information available now for this course. That program that you will find is a little bit different from what I will do in practice, because it's the program of the last year course. There are two main differences. One is that we have decided to remove the part about probability and mainly probability. This is because this part um, is already done in other courses, and more in particular in the other course that is in parallel with this one, um, about signal processing. So the fundamentals of signal processing. I don't know if the name is the same. You have all the theoretical part about probability. That part is not used in the remaining part of the course, so this is why I decided to remove it. So if if you want to uh, receive some introduction about probability and random process, then you have to attend the other course. The second difference is that I started to follow the top-down approach, so-called top-down approach, while last year and previous years they followed the bottom-up approach. Top-down means that we start from the higher layers. I will tell you later better what is the layer, but something that is very close to the applications, and then we go down as the course continues until the basic physical, close to the physical layer. Instead, in the other years, it was the other way around. So they started from the physical layer and went to the applications at the end of the course. In this way, we align the course with the other courses of 10 credits that are now taught in the first level, but also because this has become the most used way to explain networks, the top-down approach. And the book that I suggested as textbook exactly follows the top-down approach. So these are the two main differences. So if you look at the programs, the program available on the web, you will find something different, but it's not exactly what I will do. So this is the real program. We will start with the introduction and to the components and the architecture of Internet. Say something about the communication systems and introduce functional models. Mysterious word that you will better understand later on. Then we move to the top layer, which is a layer of the application protocols. I will introduce you to some protocols used for specific applications, like HTTP, FTP, and SMTP, that are for the web browsing, file transfer, and email, and say just a few words about peer-to-peer. Then we will go one layer down the transport layer, that is basically TCP protocol, how to make connections reliable over internet. We will spend a lot of time on the network layer, which is the IP protocol, so the core of the network. And we will talk about the addressing system, very important, focusing on IPv4, which is the old implementation of IP, but currently the most used and widespread. Say something about DNS and ICMP, very short information. Then we will focus about direct and indirect forwarding, routing tables, routing on the minimum path, and I will also make a very quick glance to the routing protocols, but we don't have time to go into the details. And the final part of the course will be dedicated to the lower layers, so local network technology, address resolution protocol, Ethernet, something about Wi-Fi, some, let's say, evolutions of IP protocol like NAP and IP tunneling. These are technologies very useful for intranets or for say applications for companies and private networks. And then about physical layer, I don't know if we will have time, but I will introduce the main concepts, and this will be more qualitative, let's say. So we don't have formulas and equations, but just to know what are the transmission media and their properties. This is a really temporary and preliminary schedule. So basically we will spend the first part of the course 4 hours on introduction, 4 hours in application layer, 6 hours in transport, 8 hours in IP, and then 4 hours for the other for each of the other chapters. And as you can see, at the end of each layer, we will have an exercise session or a practice session. And this will lead us to December. I hope I will be able to dedicate the last hours to do some drills for the exams. So some old exams we can solve together. Okay. So, do you have questions so far? The other observation is that this course is very dense. The topics are not so different from the topics that you have in the 10 credit version. So we will need to run. Sometimes I may ask you to complete a part by studying by yourself. I will try to avoid this, but maybe we will need it. And the time is very tight, so we have really only 50 hours, and if we lose just 1 hour, we have some way to reduce the number of topics or to take some extra time. But I will try to avoid losing time. So now I can so this slide set is already uploaded in the PDF version on BIP. So I can start the second set of slides that I will upload today. Because these concepts are really easy, so just it's not so hard to follow. So let's move to the internet architecture. So go on other 10 minutes. And first question is, what is internet? Obviously, the kids' answer is the usual kids' answer is internet is Facebook, or internet is YouTube. Internet, of course, is not that. Those are applications. Internet is the system that enables those applications. And it can be viewed in different ways. First of all, it's a physical infrastructure that is made of physical components. It's also a network architecture because this system is well organized in order to be able to work effectively. And it's also a communication service. And the communication service that is offered by internet is what I have already mentioned. So the possibility of transferring data in order to enable distributed processing or distributed applications. Internet is not actually connecting really people, it's it's a way to connect machines. Then of course people use the application, but what is speaking on the network is not you directly, but your PC or your server on the other side. So let's start looking at the physical components. First of all, you have the terminals. Terminals are different kind, maybe final user terminals like the laptop, desktop, mobile phone, tablet, and so on. On the other side, you have the servers, and we will see that servers are very important. The servers are terminals themselves, but they don't. They are not accessible to user directly, but through a remote application. And then you have all the physical interconnections, the links, the terminals are called hosts. Why hosts? Because host is a word that reminds that all these devices are hosting a process, okay? Are hosting a computer program that is talking using the network. So these are the hosts and why they are called so. Then you have links, physical interconnections that can be different types. And then you have the nodes of the network. These nodes are called routers or routers, for pronunciation. And they are really important. They are the interchange centers for the information that is flowing in the network. This is not enough. You have also other nodes. These other nodes are again devices that manage or process packets, process information, but they are used in a local area, so in a local environment. For example, access points, switches, modems, and so on and so forth. So these are the components that are making up the physical infrastructure of it. About the host. So the host sends and receives information for the final application. They execute software applications, and they can be of different types, as we have already recalled. For example, on the server side, you have hosts that are designed to respond to a lot of requests to provide services, to provide data, to provide information. So usually we need very large devices, so capable of processing information at very high speed. And the most recent evolution of the server concept is the data center. In the data center, you have thousands or hundreds of thousands of servers that are all operating by providing data or services on demand. And in data centers, but thanks to the virtualization, so the possibility of implementing virtual machines, it's not important what is the specific hardware or the specific physical machine that is taking care of a specific user, because the user is connected to a virtual machine, and this virtual machine can be migrated inside the data center according to what is the physical machine that is available at the moment. So this is the new version of the servers, using relying on the virtualization, virtual machines, and possibly implemented in very large data centers. On the other side, you have the devices for final users that, as we will see, host the client side of the applications, of software application, and you have all the sorts that you know very well. What is new is the possibility of using objects as hosts, the smart objects or the so-called Internet of Things, IoT, connected cars, connected TV sets, connected home appliances, and so on and so forth. The links are there is a very wide range of possibilities. They are divided into two different categories. One is the wired version, the wired links, where electromagnetic waves that are implementing signals are guided along a waveguide. That can be an optical fiber in case you are using high frequency electromagnetic waves, so light, or can be coaxial cable or crystal pairs in case you are using lower frequency, radio frequency electromagnetic waves. But they are all guided, so they need to be installed, of course, so they are more expensive. Of course, the advantage is that you can carry traffic with higher speed, especially with optical fibers. And then you have the radio links. Okay, so the radio links are instead less performant in terms of capacity, but less expensive. The links are characterized by different parameters. What is more interesting for our course is the capacity that is measured in bit per second. So amount of digital information you can transfer along the link in a second. So you have kilobit per second, megabit per second, gigabit per second, and so on and so forth. And also another important parameter that we will see later is the propagation delay. So how much time signals used to go from one side to the other side of the link. Then we have the nodes. As I told you, you have the routers that are the nodes implementing all protocols for using internet, and they can be of different shapes according to their position in the network. So on the edge you have light implementations. In the core of the network, when traffic is very large, you may have implementations that are even based on different racks in the room or different blades in a rack. The other types of nodes are those used in the local environment. We will talk about switches, and we will see also something about wireless switches that are the access points. In order to understand the technology, the specific technology that is used to implement a node, you have to look at which layer in the network architecture this node is used. And we will see tomorrow what we mean by layer and related technology. When you have your device, when you want to access internet, you have your device that is a host on the terminal side. I have already listed the types of hosts you may have. And also, on the other side, when you want to access the network with the server, The first thing to do is to reach the first node of the network. Once you reach the first router, then you are inside internet, the real internet network. And only if you reach a router or a router, you can communicate, send messages to everywhere in the world to the destination. So it's very important to understand how you arrive to the first router of the network. And the technology that is used in order to achieve the first router is what is commonly known as access technology. So the access link is the physical implementation, the physical mean that allows your host to be connected to the rest of the network by connecting the host to the first internet node, so to the first router. Usually, the nodes are owned by entities that are called internet service providers, which are companies specialized in providing the connection service, the connectivity service. So from your house, for example, you have to connect to the first router of the internet service provider that is providing you the connection. So it's the one to which you pay the fee, the connection fee. So in the access area, you have different solutions. In the past, residential users were connected to internet using the so-called dial-up modem, and this solution was the only possibility in order to reach a vast number of users, because everybody had a telephone network at home. So with the dial-up modem, people could send data using exactly the same network that was used for the telephone service. And the first dial-up modems were based on encoding the data, so encoding the computer information in signals that could be transferred in the voice band, the phone voice band. In fact, the first modems, the dial-up modems, were speaking. So you can hear the sounds when you were connecting to internet. This was a smart and inexpensive solution, but was very limited by the limitation of the phone voice band, that is only 4 kilohertz. So this implied a limitation in the bandwidth of the link, so in the capacity of the link, up to just 56 kilobit per second. So you can only send 56,000 bits in a second. The next solution was called ADSL, Asymmetric Digital Subscriber Line, and in this case, again, the physical medium that was exploited was twisted pair. Twisted pair is the cable that is used for a telephone service. It's twisted because it's a pair of wires that are twisted together. And so with ADSL, again, the connection, the link was the same, so still the twisted pair used for telephone, but with some advanced transmission techniques, data were sent not in the voice band, but outside the voice band. Okay? So it was a way to exploit the transmission capacity of this twisted pair, but not at the same frequencies used by the telephone service, but at other frequencies And this allowed, first of all, to be able to use the telephone while you were connecting the computer, but also to be able to uh, increase the capacity of the link. So with an ADSL line, still today, because they are very used still today, unfortunately, you can reach up to 1 megabit per second upstream. Upstream means from the final user towards the network, and in some cases 20 megabit per second from the network towards the final user. So it's so-called downstream. But these capacities very much depend on the state of the twisted pair. So if it is very long, capacity is reduced. If it is mixed together with many other user cables with many other twisted pairs in the telephone cable, you have a lot of interference. So again, the rate is reduced. Okay, so that rates cannot be guaranteed in an ADSL system. What is the solution to increase the capacity of this access connection? Is to use optical fibers. Okay? We are still talking about wired access, so we are in the category of the wired links, and the optical fiber has a capacity, transmission capacity that is really, really huge, and so basically replacing the entire access network using fibers instead of copper, or just portions of this access network, you can increase the capacity of your connection. And then here the solutions and the names that are used depends on the penetration length of the optical fiber. So if you are replacing only the first part of the access network from the central office towards the first branching point, then this is called the fiber to the cabinet, that is the solution there, this one. Okay. It's better than ADSL, but still you have copper in the secondary part of the network. Secondary part use twisted pairs with VDSL technology that is similar to ADSL but going to higher bit rates. If you want to replace all the copper, you have the so-called fiber to the home solution. Fiber to the basement if you run the fibers in the basement of the building, and then use copper for the vertical segment. All these solutions provide access rates that are really larger than ADSL. 30 megabit per second is what is considered the threshold between old service and an advanced access service, but with FTTH and the so-called passive optical network PON solutions that are currently being deployed by many providers, you can achieve 100 megabit per second, which is a fair capacity. On the other side, we have wireless access, and there are two main technologies that you can use to access internet without wired connections. The first is to exploit the cellular network. Okay. So these technologies, GPRS, that is the old one, HSP, PA, intermediate LTE is the current technology. All these technologies allows you to use the mobile phone network in order to transfer data with increasing bit rate, so from 200 kilobit per second in GPRS up to 300 megabit per second in LTE, and this allows you to not only exploit a reliable network, also in some cases be able to send data at high capacity, but also to access the network everywhere, because the coverage of the cellular network is ubiquitous. So you can be everywhere in your everywhere in the world, actually. Maybe not in the deserts or in the high mountains, but when you have access to the mobile network, then you are connected everywhere. However, this solution is still rather expensive in terms of what you have to pay for the bandwidth that you are using. So the other solution is the other wireless solution is the so-called wireless local area network. It is, for example, the way you can access internet and stay in this room by using the wireless connection, the Wi-Fi that is there. In this case, usually these solutions are for free. So if you have somebody that places antennas, then you don't pay for the traffic that you produce. They can guarantee a fair access rate, for example, up to even 1 megabit per second in the new implementation of, 1 gigabit per second in the new implementations of Wi-Fi. But the drawback is that you must be close to the base station. You cannot move around outside once you have you are out of the reach of the base station, of one of the base stations of that network, then you are not connected anymore. You have to find another network. So it's a local solution, very cost effective, but only on the local side. Okay, I think that we can stop here because otherwise it's getting too late. So tomorrow we will continue on this part, again on these general aspects.